Okay, so with this handout, where we're starting right here, we are looking at parallel and perpendicular lines. And you can see right there, you need to sketch the graph of each line and then state if they are parallel or perpendicular. I'm going to do a few of these with you, give you guys some practice. Now, hopefully before long, you can kind of determine pretty quickly if they're parallel or perpendicular, even without graphing. But the graphing part of it is still good practice because that's something you're going to keep needing to do. So let's go ahead and do just 3 of these together real quick. So if we look at problem number 1, everything here is in the slope-intercept form. Y equals mx plus b. What do we do first if we're going to graph these? Yeah, there you go, the y-intercept. So what is the actual coordinate for my y-intercept? Let's start with this one right here. Y equals 7/2 x minus 2. What is the actual coordinate for the y-intercept? -2. Not just -2. What is it? What is the coordinate?
0, -2.
There you go. 0, -2 is the y-intercept. So, of course, just as a reminder, there's your b value, the y-intercept. That's not over b. That's just underlining it and identifying it as b. So, my actual y-intercept is 0, -2. Okay, so 0, -2. Now, I'm not expecting you to write out the coordinates, but you do need to understand that -2 is telling you a coordinate. Always 0 in the x value because you're not going left or right anywhere. So 0 in the x, but positive or negative in the y direction. Okay, the 7/2, your slope right here. What does that mean? There you go. So the way that we think about this, and you might want to write this down. I know a lot of you remember it, but your slope m is your rise over your run. In this case, 7/2 means you're going to go up 7, it's positive, and you're going to go right 2, because that's also positive. If you have a negative anywhere, one of those is going to change direction. Yeah, you might go up 7, left 2 if it was -7/2, or you could go down 7, right 2. Notice one of them is still going to be going in a positive direction, but one of them will be going in a negative direction. Okay, but we'll do one of those in a minute. So anyways, up 7, right 2. So if I count that up, I'm going to go 1, 2, 3, 4, 5, 6, 7, right 2. Puts me, if I can get it to mark, right there. So all I have to do is connect those points together. It's not a perfectly straight line, but it gets the point across. Okay, next one. And I'm assuming you guys are good with that since this is all review. But let me know if you have questions on this.
Well, what about the bottom one? I know the south one. What about the other one at the bottom?
This one right here? That was your y-intercept.
The 2?
Yeah, 0, -2.
Oh, okay. And -5 is down there.
Yeah, so the next one with a b value of -5 means we're going to start it at what coordinate? 0, -5. So I'm going to put a different color right here. So 0, -5, but I still have 7/2, so I'm going to do the same thing as before. Up 7, right 2. Puts it right there. And I'm going to try and draw this as straight as I can. Not bad. Okay. So in this case, are we looking at parallel lines or perpendicular lines?
Parallel.
Parallel.
Because they never touch.
Yeah, parallel lines, they never touch each other. Okay. Now I'm going to skip over to number 4. Okay, are there any questions on that one though? All right. Pretty straightforward. Again, you've graphed a number of these lines. It's good to get more practice, though. So for number 4, we've got y equals 2/3 x minus 4, and y equals negative 3/2 x plus 2. So let's start with that first one. So what's my y-intercept going to be, the coordinate? All right, so because it's, the minus 4 at the end, that makes it 0, negative 4. I put a red dot on my graph right there. So 2/3 x. Someone tell me the rise and the run. What am I doing? Up 2, right 3. And you can keep repeating this, up 2, right 3. You can change the direction of both of them. You can go down 2, left 3, and continue that slope. So you don't have to draw all 4 of those dots on there, but if you feel like it, it helps make the line a little straighter. Okay. So now we've got our next equation, y equals negative 3/2 x plus 2. So again, my y-intercept is going to be 0, 2. We're looking at this equation right here, and the y-intercept is 2. So 0, 2 is the y-intercept. And with the slope, what do we do?
Down 3.
There you go. Down 3. Are we going left or right 2? Right. So down 3, right 2. And I'll do that a few times. I can also go up 3, left 2, as long as we are continuing that same trend. So I've got 4 dots I can connect together. All right, and it got a little wobbly, but more or less we've got the equations. Okay, so are these perpendicular or parallel lines? Perpendicular. What does it mean to be perpendicular? There you go. They don't. Not only do they intersect, but they intersect at what angle? 90 degrees. So this is right here a 90-degree intersection, and I can guarantee you it's 90 degrees. We're going to talk about that at the end. So we're just going to look at one more. We're going to go back to number 3. So it's just there to the left. And let's go ahead and look at this real quick. We've got x equals 3, y equals negative 5. X equals 3, where does that line go?
3, 0.
Okay, well, and let me ask this. Is it a vertical or horizontal line? Kind of feeling torn on this one. Remember, we're looking for the line where every x value is 3, which makes it a vertical line. All right, so we can think of it this way. If we look at this line right here, every x value on that entire line is 3. Every y value on this line is negative 5. So y equals a number is a horizontal. X equals a number is vertical. We learned that already, but just a reminder. Parallel or perpendicular? Perpendicular. There it is. So take a few minutes, and even if you can tell just from the equations what they are, parallel or perpendicular, go ahead and plot them all so we can get some practice. And then in the end, we're going to kind of talk a bit about, our main idea from this. So take a few minutes. We're going to go ahead and look at some of these that I've already completed. And you can compare what you've done, make sure it looks the same. So this is just number 7 through 10. We'll look at 11 and 12 here in a minute. So you can just compare these real quick. If you didn't get all of them done, look at the ones you did get done. And you can see right there how close you came. So again, determining parallel versus perpendicular should be pretty straightforward. Remember, with perpendicular, not only are they intersecting, but they're intersecting at what angle? 90 degrees. So they have to be intersecting like about as extreme a value as it can be. So if they're like kind of going side by side, and you're like, oh, I'm not sure if they're eventually going to touch, well, you can assume they are parallel in this case because they are not perpendicular. They'd be intersecting at 90 degrees from each other if they are perpendicular. So anyways, let's kind of think a little bit more about parallel and perpendicular as far as the equation goes. So if we look at the last two right here. So I actually meant to have these done already, but I'll just do it real quick. So we've got y equals 1/2 x minus 2. So 0, -2 is my y-intercept. 1/2 is going to put me basically right there for my first one. And then 1/2 minus 5 is the next one. So that's going to put me right about there. Okay, so these are parallel. But I want you to start noticing something in the equation itself that's going to help you determine this. So 2x plus 5, if you've already done this, you can just start looking at the equations for all of these. All right, and then y equals -1/2 x. So when you don't have a y-intercept, and there's another one like this, then it goes where? Where does the y-intercept go? If you just have y equals -1/2 x, where's the y-intercept? At 0. So anyways, let me go ahead and draw this on real quick. Okay, so make sure you're paying attention. So here's what's happening. What do you notice about the slopes when it comes to your parallel lines? Make sure you're taking this note as well. Okay, if you have parallel lines, it is the same slope. You can look at that with any of these examples. Same slope. And that one's pretty straightforward. Hopefully you already knew that one, but if you didn't remember it, it's a really easy concept to look at and verify. So we've got 1/2 and 1/2 in number 11, and sure enough, same slope, they're parallel. Now, what's going on with perpendicular?
It's the opposites.
Okay, opposites, what were you adding? Okay, so we're changing the sign. So we're going to summarize this in a different way. So it's opposite. When you said opposite, what did you mean?
Like one is like 1/2, and then it's like 2/1.
There you go. So we have a name for that. So Kevin just pointed out that we go from like 1/2 to 2. We also changed sign, okay? And we'll come to the changing of the sign. But we go from 1/2 to 2. Does anyone know what we call that whenever we take our fraction, we just flip it? There it is. Reciprocal. Okay, so we are taking the reciprocal of the slope and we're changing the sign. So perpendicular, I'm just going to say slopes are negative reciprocals. And it doesn't matter which one you start with. Both of them are negative reciprocals of the other. So we'll just do an example here. We already have a bunch of examples on the page, but if I gave you a slope here of -7/9, what would a perpendicular line have to have a slope of? 9/7, positive 9/7. Because you just take that 7/9 and flip it, and then change the sign. We can do another one just real quick, because it's pretty straightforward. Let's do 8/3. That 8/3 is barely squeezed onto the paper. Sorry, you can't see it. But if I have 8/3, what is the perpendicular line? What is a perpendicular line going to have as the slope? It's going to be 3/8, but positive or negative? Negative 3/8. So I'll try and write this a little bigger. All right. Kind of a straightforward idea. I mean, not immediately intuitive. You're not just going to do a pair of perpendicular lines and understand that necessarily. But hopefully you can see that in everything that we've done on this page, that the slopes are negative reciprocals of each other. Okay, so at the back side of that page, we're going to do as much of this as we can today. And the first part of this is going back to some transformations. We are looking at 9 triangles on a graph. And I promise we're going to tie that back in, but we're going to finish this worksheet tomorrow. So we're going to kind of tie back in that parallel and perpendicular line idea. So on this paper, those 9 triangles need to be rotated around point X. We're going to do 2 of these as a class, and I'll give you some time to do the remaining ones. There are common mistakes that happen. Now, first of all, I'll say you're rotating 180 degrees. So for every one of these, X is the midpoint of one of the sides of the triangle. Look at all of them. If you look at 1 through 9, you're going to see X is a midpoint. Now this kind of helps us. There's really only one point that rotates, because one point's going to rotate onto the other. 2 points are going to rotate onto each other in each case. So notice, this is going to rotate onto that one right there, and this is going to rotate onto this one. Does that make sense? So really, the only point I need to worry about rotating is this third point in my triangle, the one that's not on the line. Now, there's an easy way of doing 180 degree rotation. We can just draw a line going through. Notice how I took that third point. I went through the center of rotation. I went the same distance on the other side. That's where it's going to end up. Okay? If you want patty paper to do the 180 degree rotation, I've got it on the front. But we can make this go really quick just by taking that third point in every case, going through X, and then going just the same distance on the other side. So that's going to put me, I'm going to erase that line just so, it's going to make my point right here. It's going to make my triangle sit right there. Now when we rotate these triangles, we're creating quadrilaterals. And that's the whole point. So let's just do one more of these real quick. So let's do number 9. Actually, let's do number 7, because that one's a little bit weirder. So my third point is this one down here in the bottom right for number 7. Is everyone with me? Yep. And I'm going to take this, I'm going to draw a line through X and go the same distance on the other side. So I'm going left 3, up 1.5. I'm going to go left 3, up 1.5, which is going to put me, I got a little off, it's going to put me right there. The other 2 points will land on each other, so I don't need to worry about them. Okay, so that's going to leave my point right there. So that's a pretty easy method for doing the rotation. But if you want the patty paper, you can use it. Go ahead, rotate the other 7 of these, and then we will talk about what we're looking at. So we are going to be looking at 4 quadrilaterals. We've got parallelograms, rectangles, rhombi, and squares. Parallelograms. What do you guys know about parallelograms?
They're parallel,
All sides are parallel? Well, kind of. What's a different way of saying that? Not all 4 sides are parallel to each other. Okay, the opposite sides are parallel. Every opposite side is parallel to each other. All right, and in fact, we can even add something about that. So, opposite sides are parallel, and that kind of summarizes it. Opposite sides are parallel. So it says, what are things we notice about the shapes? But these are kind of things we should know about the shapes. So I'm just going to write them down from the beginning. Rectangles. What is it that's special about a rectangle? Well, that is true. Opposite sides are still parallel on a rectangle, but that's just a parallelogram. So what makes a rectangle special? That's also, we'll find out that's true of parallelograms too. So let me go show you something real quick. Which of these is a rectangle? Top or bottom? The bottom. How do you know the bottom one's a rectangle?
It's got 90 degrees.
There you go. That's the key thing. The angles are what? The angles are all the same. They're all 90 degrees. So I'm going to say 4 congruent angles, which in this case is 90 degrees. The rhombus, this might be the one that you guys have forgotten. I know you would have learned about this in the past, but what is a special characteristic that defines a rhombus? Okay, I'm sensing a lot of confusion on this one. So I could have kept that parallelogram, but let's look at this again. I'm going to draw 2 shapes here. Oops, let me try this one again. Which one of these is a rhombus? The bottom one is. And what do you think makes that one a rhombus compared to the top one? All the sides are equal. Now, I might not have drawn it perfectly, but all 4 sides are congruent. The angles are not, but all 4 sides are. And that's what makes a rhombus a rhombus. So a lot of times people will call it the diamond shape. And when you see a diamond, that typical diamond shape, that is a rhombus. But the key characteristics is that we've got 4 congruent sides. And of course, you guys know squares. So what makes a square a square? What do you got?
All the angles and sides are the same.
There you go. 4 congruent sides, 4 congruent angles. And we're going to dig into some other characteristics, 4 congruent sides and 4 congruent angles. It's not just these properties. There are some other properties we're going to be learning about in the next over the next few days. Thank you. But those are the kind of the defining characteristics. If you're just looking at a shape and you're trying to determine what it is, then this is going to help you. So this kind of ties back into the what we were just doing with the parallel and perpendicular lines. One of the hardest decisions you're going to have to make when you're determining what shape you're looking at is, am I looking at a rectangle or a parallelogram? You might be able to look and kind of identify, but we have a way of testing it. If it is a rectangle, we should have 90-degree intersections. We should have perpendicular lines. So let's look at number 1. We're going to identify if we're looking at a parallelogram, rectangle, rhombus, or square. And with number 1, what's your initial thought?
It's like a rectangle.
Okay, I heard someone say rectangle. All right. We don't have any trapezoids as part of this. We will talk about trapezoids later in the year. Well, how many of you think this is a rectangle? Okay, we got at least one person saying that, but maybe other people are thinking it. How many people think it's a rhombus? How many think? I doubt anyone thinks it's a square, so let's skip that. How many people think it's a parallelogram? Okay. Still kind of split, but more people are thinking it's parallelogram. So let's just say it's between a parallelogram and a rectangle. Here's the whole point. Now we can test to make sure. We don't just have to look at it and guess, is that 90 degrees or not? We can actually test it. If this is 90 degrees, this line right here that I just marked in purple, should be perpendicular to this line right here that I marked in blue. So you just need to get the slope of both of those. What's the slope of that line right there? We don't need the entire equation. We just need the slope. Okay, finding the slope should be really straightforward. You've been doing this since junior high. And we did it earlier today. What's the rise? What's the run? Yeah. Up 2 over 4. And let's simplify that down to what? Two over 4 simplifies to 1 over 2. There it is. So there's the slope. Okay, let's get the slope of the other side. Rise over run. What do we have for this one? 2 over 2, but okay, there it is. We're going down 2, or you could say up 2 and left 2. Whatever the case, you're going to have a negative in there. Down 2, right 2. And I'll kind of show that real quick. There's down 2, right 2. And that simplifies to what? Yeah, negative 1. I'll even write it as negative 1 over 1. So remember, if they are perpendicular, they should be negative reciprocals. The negative is there, but are they reciprocals? Okay, does 1/2 flip and become 1? No. If it flipped, it should become 2. Negative 2 in this case. So this is not a negative reciprocal. These are not perpendicular lines. This is our test to determine if we're looking at perpendicular lines. They have to be negative reciprocals. These are not, so this is, in the end, a parallelogram. So we can kind of summarize this. We can say, if the slopes are negative reciprocals, it is a rectangle or square. But square is going to be easier. So I'll just kind of add a little note about that. Slopes must be negative reciprocals. You can add this note wherever you can. So we have time. We can quickly look at another one of these real quick. Anyways, let's look at number 5. Another one of these that's kind of a 50-50. Is that a parallelogram or a rectangle? And rather than guessing, we're going to determine for sure. So the slope of this line right here, what is that one? Two over 4, which simplifies to 1 over 2. This line right here, we're just going to an adjacent side. It could go to the other one. But anyways, the slope here is what?
2 over 1.
Positive or negative?
Negative.
There you go. It's down 2, right 1. Negative 2 over 1. Are those two slopes negative reciprocals?
No.
Does 1 over 2 flip to become 2 over 1?
Yes.
Yeah. And are they negative? Are they opposite signs of each other? There you go. These two are actually perpendicular. I'm going to draw in my right angle. I've just shown that these are 90 degrees. So number 5 is a rectangle. Okay. Now you can look at this a little more. We're going to wrap this up on, tomorrow. We're going to go over the test, and then we're going to wrap up with this worksheet tomorrow. So bring it back